Hello everyone, my name is Paul Argyros. This is a demonstration of my final project for UCI's Introduction to Digital Logic and Hardware Architecture. As you can see, I'm using an AVR STK600 with an ATmega2560 microcontroller. It's set up for ISP programming, which is this cable here, which basically allows me to program the board through the USB cable. For my project, I chose to do a Fibonacci sequence, which will display Fibonacci numbers through the LED lights represented in binary. To do that, I connected the port B header to the LED header, and then for some user interaction, I connected the port D header to the switch header. The board is off right now, so let me turn it on. The device is currently erased, so no program is currently running. Let me program the board. So as you can see, now it's starting to cycle through the Fibonacci numbers. And for those of you not familiar, by definition, the first two Fibonacci numbers are 0 and 1. The next number is the sum of the previous two. So 0 plus 1 is 1. So the third number is 1. Then the next number is 1 plus 2. 1 plus 1, which is 2. 2 plus 1, which is 3. 3 plus 2 is 5, so on and so forth. The highest possible Fibonacci number that can be represented here is 233, since we can only go to 255 with the 8 LED lights. So the numbers being shown here are 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, 144, and 233. And then it continues to cycle around. And like I said, I added some activity to these switches here. So if I press switch 1, we have switch 0 through switch 7. If I push switch 1, it will stop the current, whatever Fibonacci number it's on, it will stop there and just continue to display that number. Switch 2 will resume the cycle from where it left off. I can press switch 2 again to stop it. Switch 1 to stop it. And then switch 0 will actually display the inverse of the current Fibonacci number. So it'll basically XOR the current Fibonacci number with all ones. And it basically shows the inverse of the Fibonacci number. And I can push switch 3 again to resume from the last Fibonacci number. Now if I press switch 0 again to show the inverse, and then switch 3 to resume, it does nothing, and that's by design. I only wanted it to resume only after switch 1 was pressed to stop. So after I push switch 1 and then switch 2, it will resume once again and continue to cycle around. And then the last switch I did was switch 7, which just does a reset. So I can stop it, show the inverse, and then reset. And that's pretty much it for my demonstration. There's a lot more information in my presentation. Feel free to take a look, and thank you.